All right, so this is a video on free fall example problems, essentially showing you how to do free fall problems, applying our physics to these scenarios. All right, so the first one, our medium problem, is pretty simple. Ball's just dropped. All right, we know as soon as the ball's dropped, so this is number one, as soon as the ball's dropped, its initial velocity is 0. When I drop something in my hand, it starts at rest. We also know that once it leaves my hand, it has an acceleration of -9.8 meters per second squared. All right? Now, we want to know how fast it's going, so we'll look for V final. After 3 seconds. So everything I'm writing down here is an organization of the information that I'm getting from the problem. So I see what I have, I see what I need, and I recognize that I'm using my constant acceleration equations. So there's only 3 of them, so there's 3 possible equations I could use. Well, from experience, I see I'm going to use this. All right, and then I'm just going to plug my stuff in. -9.8 equals V final, which is what I'm looking for. It starts at rest over 3 seconds. This is going to get multiplied up here because of algebra. And I get V final, the 0 goes away. I get V final equals 9.8 times 3. I get -29.4 meters per second. The negative sign tells us that it's going down. And that makes sense because if I let something go 3 seconds later, it is going to be going in the down direction. All right, so there's our final velocity for 1. And the second part of number 1 wants to know how far the object has traveled in 3 seconds. So I have the same initial thing, so this is still number 1. All right, the same initial things. I'm looking for how far. I can only use my constant acceleration equations. So I'm going to pick this one because it has delta D, which is exactly what I'm looking for, plus 1/2 a delta t squared. Delta D equals an initial velocity of 0 because I dropped it, plus 1/2 times -9.8 times the time of 3 squared. So I have delta D equals, let's see, 0.5 times 9.8 times 3 squared, 9. I have 44.1 meters, negative. All right, the math tells me it's negative, and when I think about the problem, if I drop something, it will have a displacement of negative 44 meters. It's in the negative direction. Starts up high, goes down, and that's in the negative direction. All right, so there's how we do simple problems, simple free fall problems when things are dropped. All right, fairly easy. All right, so for our second problem, we have a ball being thrown up in the air. And what you need to visualize is this ball going up and the ball coming back down. We know from class that here it has a velocity of 0. Here it has a velocity of 35 meters per second. And over here, -35 meters per second. So path up equals path down. All right? Now, what do they want to know? What is the ball's max height? So they want to know from here to here. All right? One way we could do that is, I'll show you both ways. Since we don't know how much time it is from there to there, and we don't care how much time it is from there to there, we should just use our equation with no time. Let's see if this works. Plus 2a delta d. Now, I like dropping things from the top. I'll show you how to do that in a sec, all right? But we could go from there to there, all right? That would give us how high, or we go from there to there. What we cannot do is go from here to here, all right? If we do that, look, we already know that displacement is going to be 0. I'm not trying to find the height between those 2 points because it's 0. I'm trying to find the height between that point and that point, so I have to use the velocities at those 2 points. All right, so if I do that, I'm going to show you both ways really kind of quickly here. If I go from here to here, our final 0 equals 35 squared plus 2 times -9.8, because even though it's going up, it's still negative acceleration. All right, this becomes -35 squared because it's subtracted over there. This is divided by 2 divided by negative 9.8 due to algebra, and we get delta D. And that will give us, let's see, 35 squared divided by 2 divided by 9.8 gives me 62.5 meters. Negative signs will cancel out. We're good to go. Now, if we drop it from the top, which is a totally valid way of doing it, that would just mean we're going from here to here. So our final velocity is negative 35 squared equals an initial velocity of 0 plus 2 times negative 9.8 times delta D. We can see this is essentially going to be the same equation. All right? So this gets, well, let's see, negative 35 squared divided by 2 divided by negative 9.8 gives me delta D. In this case, though, that gets squared, so that goes away, and we have our negative on the bottom here. So we actually get a negative 62.5, all right? But in the context of this problem, that just means if it dropped 62.5, it also went up 62.5. So we have how high to go? 62.5 meters, okay? Now let's move on to the rest of the parts. Sorry, we're gonna stick with this same question. I'm gonna show you a different way to do this, all right? We still got the same thing going up, coming back down. We know it's regular 35 there, 0 here, and negative 35 on this spot. If I wanted to go how high, delta T equals VI delta T plus 1/2 A delta T squared. Notice I don't have any times. All right, well, let's go find a time. Maybe I still like dropping it from the top. I like going from there down to there. Notice this delta T will be the same exact delta T as over here. So it doesn't matter which one you find. All right, I prefer dropping from the top for several reasons that you'll see kind of in the future. So what I have here is, if I do this one over here, I have an initial velocity of 0, a final velocity of negative 35, an acceleration of negative 9.8. There's our one equation, which I'm going to go back to. We saw our other equation doesn't have time, so the only one on the left is A equals V final minus V initial over delta T. Negative 9.8 equals V final negative 35 minus 0 over delta T. The T goes up there, the negative 9.8 comes out down over there, so I'm left with delta T equals negative 35 divided by negative 9.8. We have 35 negative divided by 9.8 negative gives me 3.57 seconds. So now let's stay organized on what that's telling us. All right, I'll move this over here. That is telling us that from here to here, just from there to there, our time is 3.57 seconds. Well, it's convenient in that that's also the time of our distance that we're trying to find. So now I can just go to my equation, delta D equals VI delta T plus 1/2 A delta T squared. My distance traveled, let's see, an initial velocity here of 0 plus 1/2 times negative 9.8 times delta T squared. All right, I got the time. What am I talking about here? Time is 3.57 seconds, 3.57 squared, because that's the time from the distance that we're going over. So delta D is, and we got our calculator, 4.9 times 3.57 squared should give me 62.5. Notice that it's negative because of that, and we're dropping it from the top, so it's going down, but that just tells us that it's 62.5 meters high. All right? Now the last way we could do this, same exact problem, to find how high, is simply going from here up to there. That's the way most people would traditionally think about it. From there, how high did it go? Well, path up equals path down. We already know that that's 3.57. And in this problem, we have delta D equals V initial delta T plus 1/2 A delta T squared. Delta D is equal to a V initial of, down here, 35. So 35 times 3.57 plus 1/2 times negative 3.57 squared. Do that all in the calculator, and guess what you get? 62.5 meters, and that one actually is positive. So it gives us, there's 4 different ways to get this same exact answer. All right, let's move on to the rest of these the rest of these parts of this question. All right, so we did a lot of work on part A, and it wasn't all for naught because we kind of have all the answers for the rest of them. So for part B, it says, what is the ball's hang time? Well, we've already solved for time here. All right, we know from here to here is 3.57 seconds, and to go back down is 3.57 seconds as well. Path up equals path down. Now, if it takes that long to go up and that long to get down, how much time is it total? Well, just add the two, 3.57 plus 3.57, and the total time would be, what's that, 7.14? I don't know, what's 3.57? 3.57 times 2. Nailed it, 7.14 seconds. All right, there's a total time. Hang time always refers to the total time in the air. All right, now what is the ball's velocity at 4 seconds? All right, well, we have to start here. All right, because it wants to know, I'm assuming it wants to know 4 seconds after it's thrown up. So our initial velocity is 35. I believe it's 35 meters per second. Our time is simply 4 seconds in this one. And we know an acceleration of negative 9.8. So we just have A equals V final minus V initial over delta T. Negative 9.8 equals V final. That's what we're looking for. It starts at 35, not 0, and we have 4. So we have negative 9.8 times 4 plus 35 due to algebra gives me a V final. And now I go to my calculator, negative 9.8 times 4 plus 35 gives me negative 4.2 meters per second. So what does that tell us? That tells me the negative sign tells me that it's going down. So at 4 seconds, it had already been at the highest point. It's just starting to come back down up here. All right, that's where it is about at 4 seconds because it's going down. And then the last part is kind of a trick question. At what velocity does the ball land? Well, path up equals path down. If you throw it up at 35, it's going to land at negative 35. Make sure when you're answering that question for velocity that you include the negative. If you don't give the direction on a velocity, it's going to be wrong. All right, so watch out for that little detail at the end. All right, and that's how we do number 2. And that's actually how we do anything. We showed a couple different ways of anything that is thrown up into the air. All right. Okay, so now we're on to number 3, our spicy problem. And the key to this, to start, never done these before, is drawing the diagram, stay organized on your diagram, and break it up into parts you can handle, parts that you've already been able to do. All right, so I drew this out. We got a ball being thrown up at 40 meters per second there. We know the height of the cliff is 100 meters. All right. We also know that its highest velocity is 0. Now my style is to drop things from the top. All right, drop things from the top. So I'm going to start by dropping it from here down to here, just to this part. All right, so that means my initial velocity is 0 because I'm dropping on top. The final velocity is negative 40. Path up equals path down. If I threw it up at 40, it's going to be negative 40 there, meters per second. And A is equal to negative 9.8. So I can find time with that. All right. A equals V final minus V initial over delta T. All right. Negative 9.8 equals, negative 40 minus 0 over delta T. Delta T goes up, negative 9.8 goes down due to algebra. And I'm left with delta T equals negative 40 divided by negative 9.8 gives me a time of, let's see, 40 divided by 9.8. And I have 4, I'll round it to 4.1 seconds. All right, now I said the key to this problem is staying organized. So I'm gonna have this diagram over here, all right, because I'm gonna need space to work on what we have so far. All right, what we found. We know from here to here is 100 meters. We go up. We know from there to there is now 4.1 seconds. When it's going to come all the way back down, we know here it's 0 meters per second. All right, so that's what we found so far. All right, and I'll reset that back here so you can see that it's going to be my saved copy. So now that I know the time from there to there, 4.1 seconds, I'm going to drop it from the top again. I love dropping it from the top. And I'm just going to find the distance from there to there, from dropping it from the top. Okay, so let's see how we can do that. Dropping it from the top, finding the distance. Constant acceleration, delta D, equals dropping it from the top, 0, plus 1/2 times negative 9.8. And now I want the time for this distance, just from there to there. I can see is 4.1. Notice it's very visual. I'm looking back at things. I'm not trying to keep it all in my head, even though I can, because I'm really smart, but I don't need to. I put other things in my head. So I got negative 9.8 divided by 2, right? The times 4.1 squared gives me negative 82, but then I'm just going to drop that negative and know that it went up that high. All right, so I'm going to add that to the things I know. From here to here, all right, sorry, I'm going to put that on screen. From here to here is 82.4 meters. All right? Now, what can I do with that? I'll start another diagram, all right, and see what I can do. Here's 100 meters, and now I know from here to here is 82. So that tells me that the whole entire thing is 182 meters, all right? Well, now that I had the distance over there for that whole entire side, I'm going to find distance for that whole entire side. Notice it's not a path up equals path down, because this path isn't the same as this path. All right, well, same thing, drop it from the top. Drop it from the top. Delta D equals V initial delta T plus 1/2 A delta T squared. I don't know the final velocity down here, so I can't use my A equation. So since they gave me distance, right, or I figured out distance, I'm going to use distance. All right, use what you have. Now, little tricky part here, again, this is the spicy problem. I'm going to drop from top. From there is negative 182, because it's going down. A lot of details in this spicy problem. Equals 0 plus 1/2 times negative 9.8 times delta T squared. All right, so let's do some algebra here. The 2 gets multiplied over. Negative 182 times 2. I divide by negative 9.8, and I'm left with delta T squared. So let's just do delta T squared equals, the negative signs cancel out. 182 times 2 equals divided by 9.8, and I have 37.1. All right, now I see I square root both sides to get rid of that squared. I'm left with delta T equals 37.1 square rooted 6.1 seconds. 6.1 seconds. Okay, so let me go back to my diagram and stay organized here. Here's my diagram that I'm adding all of my values to. I got that distance, I got this distance, I got this distance. Now I know from there to there is 6.1 seconds. Okay, so let's see let's go back, and I kind of forgot what we were solving for here. How high above the cliff floor does the ball go? Well, now I can see on my diagram from there to there, the answer to part A, distance from the floor is 182.4 meters. All right, because that plus that is the distance of that whole of that whole entire distance. Then they're asking for how long is the ball in the air? Well, part B then is delta t. Well, I had the 4 seconds. All right, I had this second plus, that time plus that time, right? Because that's a 4 point up to get up, 6.1 to get all the way down, and that gives me 10.2 seconds. All right, what do we got next? What is the velocity of the ball when it gets back the same height at which it was initially thrown? So if it's here, I want to know its velocity right there. Well, if it's thrown at 40, its velocity there when it comes back down is negative 40. So part C, V final is equal to negative 40 meters per second. That negative is important. It tells us the direction of the velocity. And now we have the last part. What is the ball's velocity when it hits the ground? Okay, let me get another board because we have to do equations here. Now we want to know. Now we just want to know. We got 40 here, meters per second. Thing goes all the way up, goes all the way down. I need to find V final here. Well, let's think of what I got. I got A is equal to negative 9.8 meters per second squared. I have a V initial of 40. I'm looking for a V final. I don't know that. And my total time from this point all the way up, all the way down is 10.2 seconds. So we got accelerations, velocities. I'm going to use those. A equals V final minus V initial over delta t. Let's see, negative 9.8 equals V final minus 40 over 10.2. Negative 9.8 times 10.2 plus 40, right? That gets multiplied over, that gets added over due to algebra. Gives me a V final. Go to my calculator. V final is 9.8 times 10.2 equals plus 40. Hold on, I forgot the negative sign. Negative 9.8 times 10.2 equals plus 40. Gives me negative, we'll round that to 60. Negative 60 meters per second. All right, and that's our final answer for that last one. The negative sign makes sense because when it's getting down here, it is traveling down. All right, so that's an example on free fall problems using everything we learned, but breaking it up in the parts that we can handle and using all of our little tricks. All right, thanks for watching, and I'll see you when I see you.